do here is looking at the graphical solution of equations. Equations means equal sign, and inequalities or inequations is where you've got a greater than, less than, greater than or equal to, less than or equal to sign. So, exercise 15.6 does graphical solution of equations. I'm going to add on the inequations as well. Okay, so if I might say to you, solve these. Y equals x squared, y equals 2x minus 1. So solve these equations. Now, you might think, all right, y equals this, y equals that. Why don't I just put them equal to each other? So I'm going to show you a few different ways of doing this. Now, this is the graphical solution, not the algebraic solution. So the graphical solution would be to draw them both. That's the graphical solution, right? So the graphical solution would be y equals x squared looks like this, right? 1, 1, 2, 4, and so on. So the graphical solution would be to sketch y equals x squared. I'm doing this for an equation that you could solve in a different way just to show you the method first. And to sketch y equals 2x minus 1 and read off the points of intersection. That's the graphical solution. So I'm going to sketch y equals 2x minus 1. So when x is, y-intercept's negative 1. What about when x is 1? Y is 1, I think. And when x is 2, what do you get? 3. I've drawn this very badly. Very badly. I can't even get this to work now. Bad, bad. It actually goes, no, it doesn't. Really bad. Very bad drawing. What I'll do, just one sec, I'll have to yeah, no, it's not a tangent. How can I tell how many solutions, actually? How could I tell how many solutions? I'm going to draw it in a minute. If y equals that and y equals that, can't I put them equal to each other? Y equals that, doesn't that equal that? Sub 1 into 2. You get x squared equals 2x minus 1. Let's have a look. X squared minus 2x plus 1 is 0. No wonder why we've only got one solution. There is one solution. That's why I couldn't. So isn't that just x minus 1 squared is 0? It's a perfect square. X is 1. Because I've got negative 1, 1, 1, 2, 3. So what I'm going to do, girls, my diagram is horrible. So what I'm going to do, there's apparently one point of intersection and it's at x is 1. But I'm going to do it on Desmos to show you. Because my drawing is so bad. So, or we just sketch again to scale this time. So you've got, let's just go 1, 2, 1, 2, 3, 4. So x is 1, y is 1. When x is 2, y is 4. That's my parabola. And then my straight line. I'm drawing it again. When x is 2, y is 3. For my straight line, I'm drawing it again. It's a tangent. So the graphical solution to this, so would you ever solve this one graphically? No. You would just put that equal to that and you would solve it. This is silly to solve this graphically. So to solve this graphically, I'd have to sketch accurately, right? I would just get x is 1 is my solution by reading it off the graph. How many times do these two graphs cut? Not a great one to solve graphically. Okay, let's, I'm going to go off on a tangent a bit. See how this is a perfect square, there's only one solution? I tell, you know how there's only one solution? When I combine these two equations, I get a quadratic. There's only one solution to that quadratic. Can you tell me if I did the discriminant of this, what I would get if there's only one solution? Yeah, I would get 0. My discriminant would be 0. So if I look at this, this is just notice that if I do the discriminant of this, which is b squared minus 4ac, b squared, that's negative 2 squared minus 4 times 1 times 1. That's 4 minus 4 is 0. The discriminant 0. Remember with quadratics and solution of quadratics, when the discriminant is 0, it means one Well, it means equal roots or one root, one real root. And there is one solution to this. Just noticing, just saying noticing that. That's all. All right, we'll look at another one. Let's look at, we have to solve y equals x cubed and y equals 2x graphically. So solve, it's like solving simultaneously. Now, oh, you can't see what I'm doing. These are from your book. Look, we can try algebraically if we want, but we're going to do it graphically. So if you're going to do it graphically, you would have to sketch both of them and find the point of intersection. Now, sometimes you're not going to be able to. You won't be able to see it off the graph. So I'm going to sketch. So let's sketch the cubic. What have we got for the cubic? Give me some points. When x is 1, y is 1. When x is 2, y is 8. Cubic would look like this. When x is negative 1, whatever. That's your cubic. That's the graph of y equals x cubed. The quick sketch can give you the number of solutions quickly. It might say how many solutions are there to this, okay? Y equals 2x. I think this is going to be another horrible one. Let's go. 1, 1. This is definitely negative 1, negative 1. Y equals 2x. When x is 1, when x is 0, y is 0. When x is 1, y is 2. What about when x is 2, y is 4? My graphs are so bad. Wasn't this one 2, 8? So 2, 4 is going to be down here. I know it's drawn very badly. It's going to be down here somewhere. I'm doing it on Desmos. It's a proper sketch. Please work. Projector mode. And I will put steps so you can read off the values. So here we go. There you go. And get rid of the... Oh no, we'll leave that. Okay. Let's make... Oh, I can't make this bigger, sorry, but you... Oh, okay, good. It's good now. So I've got... Look, the straight line, the points are 0, 0, 2, 4. Can you see it? Negative 2, negative 4. The straight line is in blue, right? Might get it off projector mode. Is that too thick? Right. There. So look at the straight line. You've got 2, 4. And look at the cubic. You've got 1, 1 and 2, 8. Now, tell me how many solutions there are. How many times do these graphs intersect? 3 times. So I might say to you, how many solutions are there? And you would tell me that there are 3. But if I ask you what the solutions are, can you really read it? I can't read that well off the graph. The solutions are x is 1 point something. You can't read it. You cannot read it properly. Look, because, see, they intersect at x is about 1.3 or something. If I put a dot there, it'll tell me. It's about 1.4-ish. Actually, 1.414 is the square root of 2. They intersect at the square root of 2. Oh. This graph, we do have 3 solutions, and sorry girls, it's a bit stuck today. No. It's all stuck. 1 minute. I've lost my recording. Okay, so I can see when we draw it that we've got but you can't read off the solutions nicely at all. We've got 1, 2, we could say that there are 3 solutions to the where that the curves intersect in 3 places. Now what that means, you know how I've got equation 1 and equation 2? If I want to solve simultaneously, y equals that, sub 1 into 2, x cubed equals 2x, right? So how do I solve that? X cubed is 2x. What should I do? Please don't go dividing by x. You lose a solution. Whenever you want to solve anything with a higher power, take everything to the left, put it equal to 0 and start factorizing. So how can you factorize this? X, take it out, x squared minus 2. This x squared minus 2 is really x squared minus the square root of 2 squared. Are you okay with that? You can write that as an a squared minus b squared. Anything, x squared minus any number, can be written as a squared minus b squared, which is a difference of 2 squares, just by writing, because if it was x squared minus 9, you would write x minus 3, x plus 3. But I don't have 9, I don't have 4, I don't have 25, I don't have a square number. But what I can do, if it's not a square number, any square root squared, for example, square root of 5 squared is 5. So I can write 2 as a square number, the square root of 2 squared. So what are my solutions here? If that's a squared minus b squared, isn't this x? Factorize it for me, guys. What do you get? This is now a squared minus b squared. It's x plus root 2, x minus root 2. So even though, and do you remember when we were hovering over this graph and I said that's 1.414, that's the square root of 2. Use your calculator. Square root of 2 is 1.414, etc. So this is actually square root of 2. The coordinates here are square root of 2, 2 root 2, because once I know x is square root of 2, so here are my points of intersection. X is 0, negative root 2, and positive root 2. So that means my points of intersection are 0, 0, root 2. What's the y value? When x is root 2, I get 2 root 2 for y. What do you think this point is? And I know the graph's not great. What's this point? Negative root 2, comma, 2 times negative root 2 is negative 2 root 2. But see, when I ask you to solve, solve graphically, it's often just asking for the x values. So my solution of x values, by putting the two equations together, are x is 0, x is negative root 2, x is root 2. I could say that there are 3 solutions to the equation x cubed equals 2x, or the equation x cubed minus 2x is 0. There are 3 solutions to that equation. So there are several types of questions they can ask you. They might say, how many solutions are there to this equation? So you would sketch y equals x cubed, y equals 2x, and see how many times they cross over. That's how many solutions. If they want to know what the solutions are, you'd have to do it algebraically and factorize. But now remember, you can factorize something like x squared minus 2. Okay? So, therefore, there are 3 solutions to the equation. Let's go back to the first one. How many solutions? There was only one, wasn't there? Where do the 2 curves intersect? So the first graph you did was y equals x squared and y equals 2x minus 1, and they only cut at one point. So therefore, how many solutions? There's only one solution to the equation x squared equals 2x minus 1, or x squared minus 2x plus 1 is 0. So that's what they're asking. They're asking you to draw those and asking you to say how many solutions to this equation. The number of solutions is the number of points of intersection. Okay? Sketch. So another one, y equals e to the x and y equals x plus 2. Hence, give the number of solutions to the equation e to the x minus 2 equals 0. Now, I'll show you how we get that. All right? First sketch those two functions, hence give me the number of solutions to this equation. So first you'd have to sketch. Do you recognize what each function is? All right. So I'll do the exponential in pink. E is approximately 2.7, so 1. Right, so e to the 0 is 1. When e is 1, e to the 1 is about 2.7. It looks like this roughly. And it comes down there. The other one is a straight line graph. Now I might need to use Desmos to make this look a bit better. Y equals x plus 2. What's the y-intercept? And I might extend this a bit. So, for that line y equals x plus 2, would be really good to get an x-intercept and a y-intercept. So, what's the y-intercept? Oh, careful. Y equals x plus 2. When x is 0, y is? Oh, yeah, sorry, yes. And the x-intercept is? -2. When x is -2, oh, focus is not good, y is 0. So the line goes from -2 to +2. That's the x and the y-intercept. And when x is 1, y is 3. So it's slightly above. So I've got 1, 3 on my straight line. But on my curve, I don't have 1, 3. I've got 1 what? When x is 1, y is e. Remember, e is just below 3. So you want 1, 3 being above 1e. So tell me how many, but it's saying how many solutions to this equation. So what I do, equation 1, equation 2, I'll put them equal to each other. How do you think they're getting that? So I've got, if I put 1 equal to 2, equation 1, sub it into 2, I get e to the x is x plus 2. How are they getting that? All they're doing is, what are they doing? How do I get that? Take it all over to the one side. So looking at sketching e to the x and x plus 2, drawing them both and finding the points of intersection is actually the solution to that equation, because you put them equal to each other and that'll tell you where the points of intersection are, and then you take everything over to the left-hand side and then you end up with that. So to get the solutions of this, e to the x minus 2, you actually sketch these two and read off the solutions. Now the solutions are not, you can't read it off the graph. They're not nice values. But I could say, how many solutions are there? How many points of intersection are there? There are 2 solutions to the equation. E to the x minus 2 equals 0. Why? Because there are 2 points of intersection. But then I might say approximate. If you were given a nice graph of it on grid paper, you could approximate what the solutions are. And we will have a little look. So the solutions are x is approximately equal to, now in Desmos, y equals e to the power of x and y equals x plus 2. You can see that the solutions are approximately, here I'll just click, about 1.1-ish. That's the point of intersection. 1.15 is an approximate solution. And there's the other one. Look, it does it for you. So the solutions are x is approximately 1.15-ish and negative 1.84. They're the approximate solutions. Of course, you can't do that if you're just doing a sketch on paper, but I can see that here on Desmos. Okay? So this is when, for example, if I asked you to sketch y equals, now notice, no, that's okay. All good. So, for example, you can't sketch this using algebraic methods. You can only solve this, you can only solve this by sketching the 2 functions, e to the x and y equals x plus 2, and then reading off the points of intersection. You could only get an approximate solution, or the other question you could answer is how many solutions are there? All right? I don't know if we need that domain. We'll just have a look. So sketch y equals log to the base e of x, which is the ln x curve. Do you remember that one? And y equals x minus 2. In the domain from 0 to 2 pi, don't worry about this yet. I think they've just put that because all the other questions in that particular question had sine curves and cos curves, which we're not doing till the next topic next week. Okay, so sketching those two, how many solutions to the equation log to the base e of x minus x plus 2 is 0? So first we do a sketch. Do you remember what your log curve looks like? Y equals x minus 2 is a nice straight line. Where does it cut the x and y axes? What's the y-intercept? X negative 2 and when x is 2. Yep, so there's your straight line. It'd be best to always do the straight line first, because at least that's linear. Okay, and y equals, so that's y equals x minus 2. Do you remember how the other curve looks? Y equals log to the base e of x. You can always do a little table of values if you want. X, y. Y equals ln x. What value are you not allowed? Calculator. Negative 1 for me. Tell me what you get. Error. So is it giving you an idea? So ln 0 is error. All right, let's do ln 1. What do you get? 0. Let's do ln 2. What do we get? Good. And roughly, can we do ln of a half, please? So I've got 2 is less than 1, like when x is 2, you get something less than 1. So 0.69. And what do you get for ln a half? All right, so it's going down. Do positive 0.1. 0.1 should be pretty negative, as in fairly negative. All right, this is the log ln x curve. You know how e to the x, look, up here. E to the x goes up like that. Guys, ln x is this way, ln x. It's the reflection in the line y equals x. They're inverse functions. So this is y equals log to the base e of x. Okay, e to the x is like that up there. They are reflections in the line y equals x. You know how e to the power of something and ln of something, they undo each other when we were doing the exponential and logarithmics topic? It's because they're inverse functions of each other. It means that they are a reflection of each other in the line y equals x. Solutions. You can see how many solutions. Therefore, so it's asking solutions to that equation. Why? Because I put these two things equal to each other. So I've got y equals log to the base e of x, y equals x minus 2. So I go log e to the x equals x minus 2 if you want to find the solutions. And then I take everything over to the left. So therefore, when I take everything over to the left, where does this equation equal that one? Take everything over to the left. This has two solutions. And, all right, give me the values of x that I'm going to get rid of this domain. I don't want that for this question. Get rid of it. Tell me approximately what you think the solutions are. Give me an x value here, roughly. Tell me what it's between, at least. Yeah, it could be about a half, or it's definitely between. The x value where these intersect is definitely between 0 and 1. And the x value where these meet, well, I know that this was the point 1.69, no, 2.69. I don't know what the point 3 is. Can you do 3 in here and tell me what you get? So when x is 3, what do you get for y? What's ln 3? 1.09, but on the other curve, when x is 3, we got 1.09. I don't know, it could be between 2 and 3, or is it higher? 3 is 1.09, but when x is 3, you get 1. So we want to zoom in. On the straight line, when x is 3, you get 1 on the straight line. But for the curve, when x is 3, you get 1.09, slightly above. Do you get that? So on the straight line, I've got the 0.31, but on the curve, I've got 3, 1.09, so it's slightly above. So do you think the next point of intersection is above 3 or less than 3? All right, point of intersection between log y equals x minus 2. Look at our points of intersection. So here's one. There it is. So, and you know how I was saying on the straight line graph when x is 3, y is 1, but on the logarithmic graph when x is 3, you get 1.09. So the red one is above the blue line when x is 3. So that's why the solution was slightly beyond 3. Yes? So my approximate solutions are 3.146 or 3.15 and 0.16 approximately. Okay, so do you want to write them down? That your approximate solutions are roughly 0.16 will do. So x is approximately equal to 0.16 and x is approximately equal to 3.15 will do. That's just giving you 3 decimal places. They're the x solutions. Now, why am I only giving you the x solutions? I'll show you why. Because I'm asking you, so we've got 3.15 is the x value, and 0.16 roughly is the x value here. Why am I asking you only for the x solution? Because I'm asking you actually how many solutions to this equation. Notice that this equation is only in terms of x. I'm not asking you for y values. If I say solve these simultaneously, you have to give me x and y values as the solution. But if I say what are the solutions or how many solutions to this, we're only interested in x values. So when I sketch them, I'm only interested in the x values if I'm asking you to solve this equation in x. That's why here I'm only giving the approximate x values because it's with reference to this equation only in terms of x. Okay, it's different to say solve these simultaneously. You have to give when x is this, y is that. When x is this, y is that, if it's that. But if it's only an x, only give me the x solutions.